那另外呢，在今天的活动现场啊，我们也非常荣幸的邀请到了来自海外的朋友 ，DEEPX 首席执行官兼创始人，全球半导体领域的领军人物金鹿元博士，请他为我们讲述如何携手百度将 AI 芯片之梦变为现实。Let's give a warm welcome to Dr. Lokwon Kim， 掌声有请。
Good morning. 안녕하세요. It's a great honor to be here with Baidu AI at ERNIE Moment. DEEPX develops on-device and physical AI semiconductors that enable AI to run directly on devices rather than in data centers. It is now beginning to perceive, decide, and act in physical world. Baidu is one of our most important partners in making this vision reality. I would like to briefly introduce myself. After earning my PhD at UCLA, I pursued my career at leading companies, including Apple, IBM TJ Watson Research, Broadcom, and Cisco Systems. In 1990s, the shift from Intel CPUs to ARM changed everything. Low power, less heat, and smaller systems unlocked mobile computing at scale. Let me walk through 3 moments in this demo. First, AI accuracy. Here we see our DX-M1 and a general purpose GPU running the same AI models and delivering almost the same recognition result. Second, the performance you will see at the DX-M1 matches the real-time performance of the GPU. However, on top of this, DX NPU provides 20 times better in price and energy efficiency. And now we compare with other NPU solutions, and we place butter on both NPU systems, and while they run the same AI task, our NPU stays cool and stable, while the other NPU heats up and melts its butter. Please just see that, yeah. So let me a little bit explain more. The power cost, we provide 20 times high performance. When we compare with the other NPU solutions, we gave the same AI workload like this, and we placed the butter on the same on the NPUs. So every NPUs melted its butter except for DX NPU. This is evidence of our power efficiency technology. These 3 things, The 3 things shows what physical AI really means. The same accuracy, the same performance, but radically low power, low cost, and smaller footprint. So AI can be embedded everywhere in the physical world. I believe our collaboration with Baidu AI across the 4 key areas will create a profound effect in the AI industry. First, we have successfully ported Baidu's PaddlePaddle OCR models onto DX NPUs, achieving more than 10 times better power efficiency and cost efficiency compared to GPUs. We will now expand this beyond drones, robots, and factory automation. Second, we will open a collection of AI algorithms optimized for DX NPU to the global AI developer community, enabling developers to build applications and deploy AI into devices on the fly. Third, by leveraging generative AI workflows, we will make it possible for even non-engineers to develop AI applications that run relatively on DX NPU, democratizing on-device AI deployment. Finally, we are preparing a physical AI solution capable of running large-scale generative AI models, such as ERNIE, at under 5 watts of power, enabling real-time intelligence directly in physical systems. We have successfully ported PaddlePaddle OCR algorithms onto our DX-M1 NPU, demonstrating faster performance than GPU cards at under 5 watts of power. This enables AI deployment in industrial environments where GPUs consuming over 300 watts are simply impractical. Building on this early success, we now aim to bring PaddlePaddle's drone, robotics, and factory automation AI models onto DX NPU, realizing the full potential of on-device and physical AI in real-world systems. So, is that in the real-time manner, it automatically translates the handwritten character into the digitalized document. We aim fundamentally remove the barriers that prevent AI from being deployed in real industrial environments. We will pre-port AI algorithm from PaddlePaddle ecosystem onto DX NPUs and openly publish the results, so that as soon as the application developers refine their models, they can deploy them directly into devices and put them into industrial operation without delay. Our open source Physical AI Alliance operates in 3 simple steps. Step 1, developers select Baidu AI models for their applications. Step 2, developers immediately evaluate performance on DX chip using clear deployment relevant metrics. Step 3, developers purchase the hardware platform that meets their target performance requirements. This approach allows application developers to build AI solutions with guaranteed industrial deployability from day one. Our third collaboration focuses on AI-powered developer experience. This real bottleneck in AI deployment is often not the chip. It is installation, tool chains, compatibility, and time to first success. Here we demonstrate true plug-and-play deployment powered by Keynote. Generative AI now performs on-the-fly SDK installation, dependency resolution, automated system checks, and direct model execution on DX NPUs. This means that AI itself becomes part of the development process, enabling even non-experts to build and deploy AI applications with confidence. DX is building the missing hardware layers that let Baidu ERNIE move from the cloud into the physical world. With DX-M2, large-scale generative model can run under 5-watt power envelope directly inside industrial sites, drones, and real robots. This is how agentic AI becomes embodied intelligence, ERNIE as the brain, DX-M2 as the on-device engine that makes decisions happen in real time with privacy and reliability by design. We are already proving this direction with Hyundai Motor Robotics in real deployments, and our results showed multiple times higher on-device LLM performance versus leading Qualcomm class platforms with better power and cost efficiency. Today, global capital markets are mobilizing trillions of dollars to expand AI infrastructure. But that trajectory has 2 compounding risks: a growing economic burden and a growing environmental footprint. So we ask a different question. What if we can scale AI capability without scaling data centers at the same rate? The chart on the left shows the mechanism. As large generative AI models can run locally on devices, the volume of AI traffic that must be sent back to data center drops sharply. In other words, every step forward in on-device model capability reduces cloud dependency, cost, and energy overhead. That is exactly why DX is building a generative AI semiconductor optimized for MOE class workloads in a strict edge power envelope under 5 watts. This goal is straightforward: bring higher-level intelligence into robots, drones, and in industrial systems where latency, privacy, and reliability are not negotiable. And here is a bigger vision with Baidu AI. Baidu has the world-class models and platform ecosystem to drive real adoption globally. DeepX provides the on-device engine that makes those models deployable at massive scale across the physical world. Together, we can make the edge at the first layer of AI infrastructure, absorbing the majority of the inference traffic before it ever reaches the cloud, while the cloud becomes the layer for just orchestration and training. This is how generative AI spreads beyond a few hyperscale regions and becomes a global utility, distributed, efficient, and real. To scale, we must build ecosystem, not one-off projects. That is why we are investing in global collaboration with Baidu AI, community hubs, meetups, courses, and industry pilots. We will localize edge tutorials for real verticals like robotics, smart city, and factory. We'll work with academic and university alliances to create a reliable pipeline of developers who can build and deploy based on Baidu's ERNIE and PaddlePaddle ecosystem. This partnership matters because China is setting the pace for the real-world AI adoption. With Baidu AI, we are not building a demo, we are building infrastructure. Baidu's models and platform will drive the ecosystem, and DeepX will deliver the efficient compute that brings intelligence to edge reliably at scale. Together, Baidu AI and DeepX will make AI operational across China's industries and cities and globally. I believe the collaboration between DeepX and Baidu AI elevates each of our technologies to the entire new level of value. On this stage, I would like to propose a shared vision: co-innovate, co-deploy, co-scale. Thank you.
Thank you so much for the great presentation. Thank you.